హాయ్ గైస్, వెల్కమ్ టు మై యూట్యూబ్ ఛానల్ సుశ్రుత. మన ప్రీవియస్ వీడియోలో మనం ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ అంటే ఏంటి, అసలు ఎలక్ట్రోఫైల్ అంటే ఏంటి, సబ్స్టిట్యూషన్ అంటే ఏంటి, అసలు రియాక్షన్స్ ఏంటి, ఎన్ని విధాలుగా వస్తాయి చూసాం. మన ప్రీవియస్ వీడియోలో మనం హాలోజినేషన్, ఫ్రిడల్ క్రాఫ్ట్స్ ఆల్కలేషన్ అండ్ ఫ్రిడల్ క్రాఫ్ట్స్ అసైలేషన్ వరకు చూసాం. ఇప్పుడు నైట్రేషన్ అండ్ సల్ఫోనేషన్ చూస్తాం. మోస్ట్ ఆఫ్ ది స్టూడెంట్స్ గెట్స్ కన్ఫ్యూజ్డ్ at nitration and sulfonation. So listen carefully, okay? First, nitration. The name itself denotes the nitronium ion goes and substitutes at benzene. First, let's see generation of electrophile. It has two steps. At first step, a proton from sulfuric acid gets added to nitric acid. So here the proton exchange takes place. This is the protonated nitric acid with a positive charge. That means at HNO3 is nitric acid, as we all know, and H2SO4 is sulfuric acid. Till Friedel-Crafts acylation, we use a Lewis acid like either AlCl3 or FeCl3 as an attacking reagent. But here in nitration and sulfonation, we use this H2SO4. See this. These are two H's as O4. H2SO4, that is sulfuric acid. Nitric acid, HNO3 means. So here an extra proton gets and attacks on oxygen of nitric acid. Here a hydrogen gets substituted. So this is known as protonated nitric acid. It's named because another proton came and it's getting added. Plus HSO4 minus. That means a nucleophile is generated. Next, in step 2, that is for this protonated nitric acid, a bond exchange occurs. So here along with the positive charge, the excess of electrons will go there and it gets neutralized. But here an electron deficiency occurs for NO2. So we will get NO2 plus. If an electron gets deficient, then positive charge will be obtained. So NO2 plus nitronium ion and H2O. This is H2O molecule. It gets released as H2O. NO2 plus is known as nitronium ion. It will be our electrophile for this nitration reaction. And HSO4 minus is nucleophile, which is generated before. Formation of carbocation intermediate. This electrophile is reacted with benzene and rhenium ion is again formed. And again for stability, these undergoes resonance, and these are the resonance structures. The mechanism is completely same for all the electrophilic substitution reactions, but the reagent and the final formed product will differ. That's it. Okay. Next, formation of product or removal of proton. Here this hydrogen is getting removed as a proton, that means H plus. So it donates its electrons to this carbon. Here negative charge is formed. Along with this positive charge, it forms a bond. So nitrobenzene, look at here, the bond is formed. Nitrobenzene is formed, and along with HSO4 minus plus the released H plus, that is proton. The released H plus, it completely forms as H2SO4. This is nitration reaction. That's it. Next, let's move to sulfonation reaction. Sulfonation reaction, the name itself says that the presence of sulfur in this reaction. Here the benzene sulfonic acid is formed. Let's see. Formation of an electrophile. Here the attacking reagent is also sulfuric acid, and the reactant is also sulfuric acid. So we should take 2 moles of H2SO4, right? Then the products formed are H3O plus, SO3, HSO4 minus, or we can write this HSO4 minus as OSO3H minus. In some textbooks it is written as like this, OSO3H minus. So here our electrophile will be this. You can ask me, sir, you said before that positively charged will be the electrophile, no? Why this will be the our electrophile? Because Here, when it reacts with benzene, this this SO3 could be divided. The bond shift occurs and S double bondo. Look here, I'll show you. Double bondo, and here a bond shift comes and it gets negative charge, and this sulfur gets positive charge. So here the positive charge is there, and here we'll get a negative charge. So this positive and the carbon has a negative charge. These both forms a bond with SO3, and here we have negative charge now. So SO3 minus. Then again, for stability, it undergoes resonance, and these are the resonance structures formed. Okay, and this is the intermediate. Removal of proton. This is the final step in even sulfonation reaction. But here, look here. First, it reacts with HSO4 minus. Then here it will be the hydrogen will be removed as proton or negative charge, and this positive charge forms a bond. See, SO3 minus. Plus the released H plus will combine with this and forms H2SO4. Fine. Till here we had a clarity. Next, SO3 minus plus H3O plus. This is formed in the first step in our reaction, and we all know it. Now see, H3O plus, and this gives rise to SO3H, that is benzene sulfonic acid, which is a final product formed, and water will be released. That's it, guys. If you like my video, please like, share and subscribe to my channel Sushruta. Bye bye, guys.